located, the connection port, time interval, which is in another word respect, it's the time at which every reader has to read, how many milliseconds each reader has to read. Also, it provides reader ID, which I didn't mention here, and the reader type, what kind of reader it is. Also, there is a field, as I mentioned, it's where here we have a fold, it's composite, which means that if we have a situation like with one logical reader, we are going to use different physical readers. We have to make it false, we have to make it true, and we have to mention in the readers field what readers they are. So, also I extended the logical reader specification in order to be able to create the algorithm. I insert properties like group name. Each group name has to be specific, unique for the neighboring group, and also maximum reader time interval and minimum reader time interval in order to be able to be in the scope of the boundary functionality and to provide to improve the functionality of our system. So also I create a logical reader, low-level reader protocol respect simulator, which actually what is doing is receiving the messages from the protocol and from the client, and when it has also the lights, each reader has lights which is and the light is showing the state of the reader. It can be yellow, green, red. Yellow means that it is enabled, green means that it is reading, and red means that it is disabled. So I made this in order to have like a semaphore to see is the division between the neighboring readers done correctly or not, to be visually detect the mistakes. And also I am showing the received messages. So if you speak a little bit, let's speak now a little bit about the operation of the LLRP. LLRP uses protocol data units called messages in order to communicate between the client and the reader, and these messages is helping to control reader operation. And two principal concepts of the LLRP abstraction of RF operation by a reader. It has reader operation and access operation. Reader operation is the time when we are reading just the tags, and access operation is when we can access to specific tag and configure it, or to insert the code inside the tag, this specific tag. Also, the timing control of the operation is specified using the boundary specification. So if we take a look to the state of the respect, we can see that when we are, it has three stages, as I told, disabled, inactive, and active. When we have add respect message, which is the configuration, which contains the configuration of the reader, it says the reader to disable state, and enable respect message is helping to change the state to inactive. And when the respect start condition occurs, it's changed to state to active. The respect start condition can be or respect start message, or it can be start trigger, which will change the state of the reader. And in active stage, it is doing a loop if it has RF survive specifications or other kind of specifications. It's every time it's looping and changing, taking one specification, activating it, reading. When it's finishing, it's checking if it has another one, again activating it, doing the job, and deactivating. So, how the simulator works, it can get the set reader configuration, add ROSpec messages, enable ROSpec, start ROSpec, and delete ROSpec. I'm using the following way. When I receive a start ROSpec, inside the message I put in the IL application variable, I inserted inside the message the duration, how many milliseconds this reader is going to read. So the simulator can get this parameter from the message, read for this specific amount, and automatically it will change its state to the, it will stop the reading. So this is the LLRP timeline that we are configuring, then we are accessing, we are sending the ROS reader operation messages, and the reader is replying back with the ROSpec report. And also we have keep alive messages from the reader, which says that the reader is alive. So let's take one example. Let's take a look to one example that I have implemented, which I think will clarify what I have done. So let's consider a situation when we have three neighbor logical readers. Each one of them has a logical reader 1 has 400 milliseconds of reading time interval, logical reader 2 has 500, and the third one 800 milliseconds. As I mentioned, inside the specification we have defined that the lowest boundary for the specification is 500 milliseconds. So what my application will do when